This question says, the particle P moves with constant acceleration 2I minus 3j meters per second squared. At time t is equal to 0, P is moving with a velocity 4I meters per second. Part A, find the velocity of P at time t is equal to 2. For part A, we can first write down all the information that we've got in the question. So we can write down suvat and fill in the values that we know. We do not know the displacement, but we know that the initial velocity is going to be 4I because that is the velocity when time is equal to 0. So for u, we can put 4I. The velocity we don't know, but we know the acceleration, and that's given in the question again as 2I minus 3j. And because we are looking for the velocity at time t is equal to 2, we could put t as 2 and we are looking for v. So using the suvat formulas that are given in the formula booklet, the equation that connects u, v, a, and t is the first equation that we have here, which is v is equal to u plus at. And if we substitute the values that we know, u is 4I plus 2, which is the time, multiplied by the acceleration 2I minus 3j. And if we expand the bracket, we will get 4I plus 4j minus 6j. And if we now add the I terms, we will have 8I minus 6j meters per second. And that's the final answer for part A. The next part of the question says at time t is equal to 0, the position vector of P relative to a fixed origin O is I plus j meters. Part B, find the position vector of P relative to O at time t is equal to 3 seconds. So for part B, we are looking for the displacement at t is equal to 3. The initial velocity still remains the same, which is 4I. The acceleration also remains the same, 2I minus 3j, but this time the t changes because we are looking for the displacement when t is equal to 3. So if we look at the formula that links S, U, A, and T, it is the second formula that we can use. So if we write S is equal to UT plus a half AT squared, we can substitute U for 4I, and that's multiplied by the time, which is 3, and then plus a half A, which is 2I minus 3j, and T squared, which will be 3 squared. So if we expand the brackets, we will get 12I, and we can keep the half and first expand the bracket with the 3 squared, which gives us 9. So 9 multiplied by 2I is 18I, and 3j multiplied by 9 is negative 27j. And if we now halve those values in the bracket, we will have 12I plus 9I, and 27 divided by 2 gives us negative 13.5j. If we add the like terms, this now gives us a final displacement of 21I minus 13.5j. So what we have found here is the displacement when t is equal to 3. So if we draw this as a diagram to understand what we're looking for, we first have the position vector when t is equal to 0, and we can therefore call that RO. We then have the position vector when t is equal to 3, which is what we've just found, so we can call that R3. And because the question says that we need to find the position vector of P relative to O, that means we are looking for the resultant vector beginning from O and ending where the particle is at time is equal to 3 seconds. So in order to find that, we can simply add the RO, which is the position vector given I plus j, and we can add that to the displacement we found, which is 21I minus 13.5j. And if we add the I terms, we will now get 22I, and plus j minus 13.5 will give us minus 12.5j.